The first problem on the sample test, we're graphing a polynomial. It's in factored form, which expresses a lot of the features. But you should note that if I were to multiply this out, the lead term would be an x to the fourth power. And also it would be a positive x. Positive and fourth power means that I kind of expect it to look something like that, a W shape, cupped up. I'll graph the x-intercepts. You can read them off in the factored form. So for example, there's 1 here at the point 1, 0, because if x is 1, this term is 0, which makes the whole expression 0. There's also going to be 1 at -1 and at -4. Those are my 3 x-intercepts. For a y-intercept, because I do ask to include all intercepts, you would plug in x equal 0. If x is 0, you would have a -1 times a +1 times a +4. That would be -4. If the number is very large in relation to the axis, just mark it. You don't need to keep the x and the y-axis the same ratios. In this case, -4 isn't hard, so I'll just go 1, 2, 3, 4, and there's the point 0, -4. Now, to figure out the behavior, if it's a single root, as in the case with x plus 4 and x minus 1, it's going to pass through. A double root would bounce, and a triple root would go through, but would go through with a slope of 0 temporarily. Reading from the left to the right, I start above the axis. X plus 4 is a single root, so I expect to go downwards, like this. Next, I approach -1. That's a double root, so I expect that that is going to be a bounce. I expect it to rise up, touch the axis, and then go back down. The last factor, the x minus 1, that is going to give you a single root, so you're going to pass up through it again. And of course you have to get to this point. Well, now you just have to put all of the information together. So it's going to be falling, go through that point, rising, touching, coming back down, going through, and rising again. And that will be the shape of this graph.